Okay, let's talk about proportion boxes and ratios and rates. You can use these proportion boxes if it says find the percent or part or whole. If they give you the ratio of 3 to 5, you can find the percent. We remember that we put the percent here, the 100 here always, and then we cross multiply the two that are diagonal, and then divide by the number that's left over to find the percent. And we always put the percent here, the 100 right under it to find a percent. You can also find the whole or the part if they give you the percent by doing the same thing. Okay, you can also find a unit rate. If we, in 3 minutes, if we're able to text 15 text, and I want to know the unit rate, I have to think, where does my 1 go? Because I know that 1 is a unit. Do I want to know how many parts of a minute it takes me to do 1 text, or do I want to know how many texts in 1 minute? 1 minute is what I need to know. So I would multiply these two, divide by the number that's left over. I can use the proportion box to find out if ratios are equivalent. We need to remember butterfly. 6 times 5 is 30. 3 times 8 is 24. These are not equivalent ratios. Okay, and then you can also use this proportion box to find out what is 35% written as a fraction. Here we know that percent is a special fraction over 100. 35% is never going to be 1 over 35. It's never going to be 3 over 5. 35% is 35 over 100, and then we look to see if there's any common factors. There are common factors in 35 and 100. 5 will go into both of them. 35 divided by 5 will give me 7. 100 divided by 5 will give me 20. The simplified fraction for 35 over 100 is 7 over 20. It's just written inside a proportion box. Okay, we're going to be talking about writing a fraction in 3 different ways. Let me see if I can make this a little bit bigger. And I want to know the ratio of big eyes to teeth. And so, lock this in place. So I'm going to count my big eyes, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I would write my ratio 12, 2, with the word 2. Let's see, how many teeth do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe I counted 9. Let me count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 12 to 9. I can also write that ratio 12 ... or colon 9, and I can write that ratio 12 over 9 like a fraction. Okay, I'm going to get you to pause and do the other ratios. Now we're going to see if these ratios are equivalent. Remember, I mentioned to you that you can butterfly. And so let's make this a little bigger. And I'm going to butterfly these 2 fractions. 2 times 20 is 40. 8 times 5 is 40. So these are equivalent. You can also use the method of scaling. 2 times 4 is 8. 5 times 4 is 20. The scale factor is times 4. Okay, I'm going to let you pause and do a couple more. We're going to simplify these ratios. Remember that a ratio can be written in 3 different ways. So I'm going to write 3/6 as a fraction, 3 over 6. I know they have a common factor of 3, so I'm going to divide the numerator and the denominator by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So this would be 1 dot dot 2 as a simplified fraction. We'll pause and let you do a few of those also. Okay, the table below shows the number of children, C, to each child care worker, W. Based on the information in the table, which of the following statements is not correct? Well, since I'm looking for a not correct, I know that I'm going to have 3 trues and a false. This says the ratio of children to child care workers is 4 to 1. I have 8. Let me make my portion box. 8 to 2, and that would be children to workers. Labeling is important and the order is important. And this says children to workers, 4 to 1. So I can multiply. I get 8 in both places. So this is a true statement right here. That's not the one I'm looking for. I'm going to add on to my box here, the table. I'm going to add on another row. For B, it says if there were 32 children, so I would put 32 right here, and there would be 8 child care workers. So I'm going to look to see if that's true. This is 8 divided by 4 is 2, 12 divided by 4 is 3, 16 divided by 4, 24 divided by 4 is 6. So 32 divided by 4 is 8. So this is true. If there were 5 child care workers, then there would be 20 children. And I've got to be sure to get these in the right order because I've got 5 workers and the workers are over here. So I'm going to put my 5 right here and my 20 will go right here. Now all of these were divided by 4. So 20 divided by 4 is 5. So this one's true also. Now this says the ratio of child care workers to children is 4 to 1. So they're saying for every 4 workers, there's 1 kid. And that just doesn't make sense. That would be like putting 4 over here for workers and 1. 1 divided by 4 is not 4, it's 1/4. So this one is not true. This one is false. This is the one that is not correct. A factory is able to manufacture parts for a ceiling fan. Based on the data shown in the graph below, how many parts can the factory manufacture in 14 hours? Well, when I'm looking at this chart, I look and I see that they have parts and they have hours. And I notice that the only dot on here that's exactly on the lines is the one at 5 and 60. So I'm going to make a rate table and I'm going to label this parts because this is parts and this is hours. And so it looks like I have 60 parts in 5 hours. My unit rate, I would want to know how many parts per 1 hour. 5 divided by 5 is 1. 60 divided by 5 is 12. I have to think, how do I get from 5 to 1? How do I get from 60 over here? I do the same thing. I divide by 5. So now I know my ratio is 12 to 1. I can add on to my proportion box and kind of make it into a rate table. I want to know how many parts it can manufacture in 14 hours. So I think, do I put my 14 on the top or the bottom? And I put it on the bottom. And then I can multiply 1 times 14. And then I multiply 12 times 14. And I'm going to let you tell me what that answer is.